So as you tested the robots, you guys found out that during the maze challenge that the battery may have affected just a little bit what you were doing. The voltage of the battery, maybe your wait time one day was a little bit different. Let's say it was 950 and the next day you had to make it 1,000. Small little changes had to be made because of the battery voltage. Well, to go ahead and bypass that, we're going to add that shaft encoder into our program. And so what I've done is it's already on the robot. I've opened up my most recent, so I keep all my user functions, make up my most recent, and then what I've done is I've gone File, Save Project As. And what that does is just let me keep all of my user functions. I did that, and then I just deleted everything in my main. So I still have my user functions, and I have my main empty. I did leave the variable there. Don't worry too much about that. But we're going to start from scratch with this program, which I've named Quad Encoder 1. So this will be our first quad encoder program. And so what I'm going to do is I'm just going to help you get information from the quad encoder, and then you all are going to figure out how to take it further from there. So the first thing we need to do is we need to go to Inputs, and we need to grab our optical quad encoder and drag it over. When we do that, we need to start the command first. So we're going to do a series of commands. We have start, preset, get. We're going to start the command. Okay, the first one is 2. It's plugged into digital 2. It's plugged into digital port 3. And we're going to press OK after we select 0. There we go. So we got 2, 3, 0. Then we're going to drag that over again. And we're going to preset our value. So 2 and 3, and it's going to set that value. It's going to start at 0. Okay, so it's very similar, 230, 230. Now we're going to need to make a global variable for our encoder. So we're going to go over here. We're going to make it a long. The type is long. The name is going to be encoder. And we don't need to worry about setting a value. We'll be all right. I'm going to press OK. So that's created inside of globals, which means any of our programs, any of our functions can use that. Now, just like we did with the bumper switch, it needs to be checked inside of a loop. So we're going to grab our while loop, which we actually created into a forever loop, simply by adding a 1. 1 means it's always going to be true, so it's always going to do what's inside that loop. So it's going to go through start encoder, preset the encoder, and then start checking. So it's going to grab information. Optical quad encoder again. This is our third time. We're going to get information. Get information. It's going to go 2, 3, and then we're going to retrieve it to save it in encoder. You can see the color difference. We've got our blue, which means it's local, and our pink. And so we've grabbed that. It's going to save it to encoder. Encoder equals get quad encoder from 2, 3. Things are looking good. Then what we want to do is we want to actually see what the information actually looks like. So lucky for us, remember in Arduino we did the serial print and the serial monitor. We have a print to screen. And so this print to screen I drag over. So we're going to type encoder value equals. Down here we're going to select our variable encoder. And the directive, because it is a long, we're going to pick LD and press OK. So we've got encoder value equals, make sure it says LD/N there, and we're showing the encoder. And so it's going to print out that value as we go through the program. We build and download this program onto the robot. Make sure your robot is turned on because you'll need it on. You'll see that the terminal window, this second window over here, is going to pop up, and that terminal window is going to give us our feedback, kind of like the serial monitor we had for the Arduino. You can see it's flashing really quickly. You can see the value, and if I lift up the robot or have it in a safe configuration, I can rotate that. Rotating forward gives me that positive value, and I go back and it takes away from that value. I can actually get to negative values. And so it's counting. In this case, it's not how many rotations the axle has made, but how many degrees it has rotated. And that's because we're using the quad encoder. Both cables are getting plugged into the digital. So That is the value that we should be looking at. We're going to use that value to get us our information.